Polygenic traits are characteristics that are controlled by multiple alleles, such as skin color and height. And these traits usually fit well on a bell curve when graphed. But different ends of the bell curve, or even the middle, can have a different fitness. And fitness is basically the measure of how much better you are surviving and reproducing compared to your neighbors. So this creates variety, and where there is variety, natural selection can act. And so when a natural selection acts on a population, in terms of the same bell curve that I just mentioned, there are three different types of selection that can happen. So first there's directional selection, which I'll draw a graph here, is basically when one end or one extreme is favored. So because only one side is favored, that means, let's see, okay, so this is the original population. Oh yeah, so this is the number of individuals, number of people. This is going to be, let's say, skin color or something. So this side is going to be paler. And this side is going to be darker. So right now our population is kind of in the middle, right? Well, in blue, I'm going to show what after natural selection acts, what our new population will be like. So for directional selection, the new population would be probably like this, something like that. So in this case, the people with darker skin are favored because for some reason, maybe they're living in like a really sunny area, and the more melanocytes they have, the better they survive and reproduce. So the bell curve would be shifted to the side. So the norm would be slightly darker because with people with darker skin, they survive better and reproduce more, so there will be more people with that characteristic. People on the other side with paler skin, well, they're not so lucky, so their offspring don't survive and they don't survive, so there's going to be less people over there. The second type of selection is called stabilizing selection, and that is where, I'm going to redraw my graph, but that is where both extremes are voted against and the middle is favored, the middle characteristic. So basically you could think of it as the people who are the most normal in a population survive better, and the graph would be like this, with the blue as the new population and the black as the old population. And let's change like the variable here, right? So instead of skin color, let's do birth weight. So we found that in the past, birth weight used to be on a much broader range, from like a super, super light baby to like a really heavy baby. But the thing is, over the years, the babies with the most normal, like in the middle of the range, they survived better. So more of those babies survived, and that trait was passed on, the trait that being a median weighing baby. And so the range actually got smaller, and the graph turned out to be like this. Now the third type of selection is called diversifying selection, and that is when it's basically the opposite. The middle isn't favored and the ends are, so like both extremes are favored. But this isn't diversifying, this isn't directional selection because both of the extremes were favored, not just one. And the middle characteristic is actually selected against. This can happen when, for example, you're in like a black or a white environment, and so the people with either like a black or white characteristic will survive, but people with gray characteristics won't, because there's no place for them. They stand out because they don't belong to either of the groups. And so, okay. The graph would look like this, except over here, this would be like, I don't know, black, this would be white, this would be gray. This can lead to speciation, because since both of them have such different characteristics as time goes on, it can eventually lead to reproductive isolation, and that leads to speciation. So that's it for the different types of selection for evolution.